Light of 540 nanometers strikes two slits that are 0.045 millimeters apart. Diffraction pattern shows up on a screen 175 centimeters away from the slits. I drew that picture to the left as best as I could using Google Slides. That's double slit. You have the light. The dot is just where the light begins. The light coming out at 540 nanometers. And then the slit is 0.045 millimeters. And then I show the distance with the arrows. The problems are asking, A, determine the distance in meters between the central max and the adjacent dark spot. B, determine the distance in meters between the central max and the second bright spot. And C, be able to draw and label that setup intensity for these intensity patterns for these. So I started with C just to be able to get a good picture of A and B, because I kind of forgot, it was quite a while ago. And you find that it's 0 is going to be your max, and then dark spots go 1/2, 3/2, 5/2, and bright spots go 0, 1, 2. So knowing that, you can go into A, determine the distance between the central maximum, 0, and the adjacent dark spot, 1/2. The adjacent dark spot could be on the right or the left. It doesn't really matter. They're the same. So you're going to use the equation distance equals m lambda length over distance. So knowing this, you know that your m is going to be 1/2. That's going to be the distance between the central, or not the distance, but the adjacent dark spot. And then 540 times 10, since the light is in nanometers, we need to convert that to meters, so it's 10 to the -9th. I forgot to add that negative in there. And then its length is 175 times 10 to the -2, and then distance is 0.045 times 10 to the -3. Solving for that, you get the distance is 1.05 times 10 to the -2 meters. Those are supposed to, see how I changed it from the last slide? Those are all negatives now. Okay, for B, it's the same equation. Now instead of using 1/2, I got confused. I didn't read this very well. So second bright spot, you're going to use the second bright spot is going to be 1. Or no, the second bright spot is going to be 2. The second bright spot is basically going to be 2. I forgot to change that in these slides. Sorry about that. It's not 3/2. That I got confused between the dark spot and the bright spot. It should be just 2. Once again, it's converting to meters. So basically the same problem. You're just changing that m variable. And you get the answer is, the distance is 4.2 times 10 to the -2 meters. And that's all.